Hello everyone, welcome back to the channel. So I haven't been doing much with the van. I shouldn't be, and should be good for now, but today I'm gonna have a little project that I always wanted to do so far. Because I built my own little house battery for my minivan camper. And the only way I can charge that house battery system is solar power. So I don't have a DC to DC capability of charging when the car is driving. So today I'm gonna try use this little device. This thing I think about $11 or so. And I'm gonna try to make this more than just one function. It's gonna be charging my house battery while I'm driving, and it's gonna be using to do a extended battery for your power station, your portable power station. All right, let's get to it. All right, so right here what we have is this is my house battery. I don't leave it in the van when I'm not driving because it's pretty cold outside right now, 19 degrees, so it's not good to leave it out there. Plus heat also damage your house battery if you're not running it or cooling it. So what I'm planning attempt to do with this little device here, this is a 12 volt to 20 volt step up inverter. So this is a portable power station that will take 12 volt charge, either 12 volt or 24 volt, right? And this is a 12 volt 12.8 volt 100 amp hour battery, lithium phosphate battery. So I'm gonna make this device go from 12 from here. As you can see, you cannot charge from 12 to 12. So you need to step it up. So it push it over here. And then I have these port. I'm gonna use this a bunch of these wire, and I'm gonna explain this a little bit later on. This require me to make a little bit of putting together with a soldering iron and wire and XD90, I believe this is. I love these things. Yeah, the XD. Let me type around here. Yeah. XT60 actually. Yeah, it have a female and male, and so that right there is my fridge. Remember this? I cut the wire and met the end, so that way I can either plug into the vehicle or I can plug into my house battery, which is not here right now, but it's down in the minivan. But that is another goal, is to use that 12 volt accessory plug. That's a 12 volt, right? So it's gonna go into this 20 and invert it up to 24 volt, and then it's gonna go through the controller, which usually your portable power station already have built-in control charge controller, which will take 12 volt or 24 volt automatically switch. Whereas in the house battery, I have to manually adjust it, change it to 24 volt charging. So that way, when 24 volt go in there in this, it will charge this up. But that's a later project. This right now, I just want to do how like a lot of name brand battery like Blue Eddy, stuff like that, will be able to have you the portable one, and then you can upgrade it up, extend it better and attach it. But they want a lot of money for that. You talk about several $100, if not thousands of dollars for extended battery. Why not make your own extended battery? This is cheap. You can get these for about what, $200-300. This is $11, maybe a little bit more material. I would say $50. And you literally can buy any 12 volt lithium battery and then make into an extended battery for your portable power station. Then you can triple or double whatever capacity of this, because it will. This usually when you charge it DC to DC, you'll be able to use everything else at the same time. So if you have 24 volt going in here, then you'll be able to use this twice or three times. It might depend on how much capacity you have on this side. All right, let's get to making the wire for it. So I'm using alligator clip that I have. I don't know, I had this a long time. That's why I knew why I saved these. So positive, negative. So I'm gonna solder into one of these ends. And then this one, this came with this for switching the orientation of the plug at the end like this. You can swap them around, but I'm not using it. It's pretty easy to swap them around without using this swap cable. But I'm not going to show you that. But what I'm going to do, I'm going to cut this in half right here, and then install one of these. It's opposite of this because you have to be a female and male. So it's going to be opposite, and then it's going to go in here. And then we're going to clip these clip into the battery, and then went through here, then from here to here using this end here. Okay, you can see, you can plug it in here like so, and then that one of that end like that, gonna go. I'm gonna solder in there, and then we're gonna go through this and this through that through these cable. All right, I bring you back once I'm manufacturing these cable. All right, I finished make the cable. Have to do a little bit of soldering. I'm gonna show you an example what it look like. Okay, not sure this is gonna focus or not. Yeah, see how it is quite easy. Take about a minute. Once you get good at it, take about a minute to put the wire and by soldering into it. And then this will separate it. Both ends from touching that inside here. You can see the little divider inside here. Let me pull it back. So hard to do it by hand. Yeah, there's a little plastic in there in the middle that will separate the two terminals from each other from touching. And then you just light it up and seal it completely. All right, let's hook this up. I'm gonna bring you back. All right, so I'm using this as a extender for this 600 watt. This is 1200 watt, 1200 mAh, I'm sorry. No, 1200 watt hour. So I literally will triple the capacity of this battery if I hook this through this inverter into the charger. All right, let's hook it up. So this is gonna go in here. Red. All right. So what I did is I make sure this end, flat end, is the red part. Same thing here. So red end gonna be red part. But that's not what I'm gonna hook up to this one right here. Okay. And this end go to here. All right, moment of truth. Always put your positive end in first. Nothing. Oh, no, there it is. You can see I'm getting 115 watt going into my portable power. It worked for $11 with a little bit of so I say about $20 total with material and everything. You get yourself a battery extender for your portable power station. And then I'm gonna try to make this into a DC to DC charger. Since I already have this, and all I have to do is make sure I have this end here, plug in there. So same. All I have to do is disconnect that one, and I got myself so that port will take 24 volt. So you want to invert from 12 volt to 24, go up, so that way we'll be able to push through. So it actually worked, guys. Okay, so we're gonna do a true live test right now. See, my goal is to be able to charge my portable, also my house battery later on when I have to make a little adapter for my controller on for the house battery. But right now I'm gonna test the portable one. See, I want to charge the portable one twice as fast compared to what the supply cable from manufacturer for the Rockpile, my Rockpile 600 watt hour, and I'm going to show you the difference. All right, let's see if it works. Okay, this is the adapter that the charging cable that come with the Rockpile. See how it coming out, like this round thing here. It's gonna be plugged into this. Of course, the bottom one is my homemade 20 volt charger that I made with a little bit contraption going on here. As you can see previously, I saw inside where I used an external battery to charge this bad boy up. So I'm gonna plug this one in with the supply cable to see how many watt am I getting from the vehicle. All right. Let me unplug this, start the vehicle. And plug it in. Let's see what kind of wattage we're getting. All right, so it's going up, 41, 46, 47, right? 48. I rev up the engine a little bit. So it's kind of limited at 48 watt per hour. So every hour you get 48 watt. So I'm gonna unplug this. I'm gonna unplug this also to show you only this cable from my homemade DC to DC charge inverter. We're gonna see how much we're gonna get from here. I'm hoping to get the exact like what we have. It's gonna take a while to spool up. Let's see. What happened here? Going. There you go, exactly like what I had inside with the external battery. So you get almost 3 times as much charging using this method. This is a what, maybe $25 contraption, DC to DC charger. Okay, you're getting 28 volts through here, so it's much faster. See, this one have a capability of receiving 26 volts. So now you can see I can charge this portable power station 3 times faster than comparing to original cable. There you go. That's my cheap DC to DC charger for portable power. This portable power station have a built-in controller. Right now, my house battery is here, so I have to configure a cable that go into the controller. So in order for me to use this contraption to charge 3 times as fast compared to normal cable. Okay, remember, in order to do a commercial DC to DC charger, you have to use cable like this, which you have. Oh shoot! Is it connected? So one of the thing that you cannot do charging like this is you cannot do the AC power. See, you can turn this on. See the light come on. You can see this on, but you cannot do AC while DC to DC charging. That's the downfall of this charging system. Even when you do solar charging, it's the same way. Let me see the cable here. It's not hot. This is a little bit warm, which is normal, supposed to. Cable is stay cool. It's not hot. Remember, the higher the voltage, the smaller wire gauge you can use. That's why with 12 volt to go straight from the battery to here, you have to use a bigger gauge cable. So with this method, this thing is pretty hot on the bottom, kind of warm on the top. That's why they have this heat sink to dissipate the heat away from the unit. So if you want to mount it, you want to mount it somewhere to have good airflow for this to work well. Still holding at 116. Remember, this 12 volt outlet can handle up to 120 watt. So you don't want to push it too much. This thing will handle 120 watt max, but it have to go through this port. But if you go through this port, you only get like what you see previously. Uh-oh, Houston, we have a problem. Even though the wire did not get hot, none of the wires get hot, this unit actually really hot. So you probably need a fan on this to keep it cool. And this end, look what happened. It's literally melted. When I pull it out, this end is right, super hot. Well, back to the drawing to see how I'm gonna get this. I don't know. Maybe I have to use that this big wire. Maybe the straight wire into the battery. Yeah, it's got really hot. Well, that did not work with this this kind of plug. So I don't know. The wire did not get hot with these. So maybe I need to have a direct connection with a higher, probably a higher amp. Since I already have the cable running through here, I might as well hook up to that. So that will be my my DC to DC cable to use this contraction in order. Plus, I need to put a little fan on this to keep this cool. Yeah, it gets super hot. There's no free lunch, you know. You gotta gain something, but you gotta lose something, which is heat. You gain more wattage transfer through, but then you create a lot of heat on this unit here. Okay, so using this method of clip, alligator clip, the wire is not, the terminal and the wire is not hot. It's not hot here, not hot here, but it's really hot right here. So you need a lot of airflow going through this. Yeah, it's really hot on this end right here, just like when I was doing it out in the vehicle. So you can see what happened to my 12 volt. It literally melt the end of this. So try to use this DC to DC charger through your cigarette lighter is not recommended. Yeah, literally, this is no good anymore. It's melted. Even though the wire did not get hot, but this end got really hot. And to see what happened right here. So I'm not recommending using this. Besides, if you want to do this, do this at your own risk. You might damage your battery. Right now, I've been running this for about 5 minutes now. I get about 2% more. Ooh, this thing's really hot right now. The heat sink does pretty good job. So you have to have a good ventilation for the heat sink. According to the spec, it say this thing's supposed to put out 75 watt, but somehow we get 115 watt there. So I don't know. This is China made, so I would add in one of the fan right here, like one of those computer fan that you can attach on top of this, so that way increase the airflow, keep it cool. Yeah, this method using the 12 volt accessory outlet is a fail. See what happened? It melted my end. So now it's no good. I have to get another end of this. This is from my fridge. So not recommending using this, but this is doable. disclaimer, do it at your own risk. You might damage your battery. I don't know. Right now, 58% went up, 58%. It's still holding, even though this is hot, but it have good airflow, then it will cool this down really good. Yeah, super hot. If I'm holding it for long, I might burn myself, so do this at your own risk. Oh, and one more thing, I would add a fuse between here, especially on the positive side here. So that way, if it's overheated, it will melt it away. So 12 volt at 120 watts, so you probably need a, I would say about 15 amp fuse right here. So if it went above, it got too hot. You don't want it too low. You don't want 10 amp, because 10 amp, you only get 120 amp, pretty close to 116 watts. You want a little bit higher. 15 watts, 15 amp would do. 15 amp fuse right here would do. Okay, so I have to do a little bit more modification to this rig that I'm doing in order for it to work right. So right now there is a potential for fire if you're not doing it right. So do not do this if you not know what you're doing. And thanks for watching. I will catch you on the next video. Bye for now.